Hello everybody, and welcome to today's chem lesson, where we're going to continue talking about electrons in the atom, how they interact, and what it means for the atoms overall. In the past, in previous videos, we've talked about atoms, and we wrote down things that looked like this. And one of the things that we talked about was the charge, and how the charge of an atom was the protons minus the electrons. And we said that these atoms would remain neutral for a while until we got to the point where we were going to talk about when they were different. Now, this video is the video where we're going to talk about ions, which is what happens when a neutral atom, gains or loses electrons. If we have an ion of carbon, we've got the same starting numbers, right? Carbon is carbon because it has a mass, or because it has 6 protons and a mass of 12. But in an ion, the charge is going to change. We're going to have different options for the charge, while all the other numbers stay the same. And what this means is that we have either gained or lost electrons. Now, this is going to start off sounding a little bit backwards when we start talking about it, but an atom that has lost electrons has a positive charge, and an atom that has gained electrons has a negative charge. And the way we can internalize this so it makes a little bit of sense, first is remembering that electrons are negative. So we're talking about adding and subtracting, gaining and losing, but we're talking about that with negatives, so it's going to flip some of the effects that you think. If we think about us as people, if you take in a bunch of negative emotions and negative feelings, you are going to become more negative. If you lose a bunch of negative emotions and negative feelings, you are going to become more positive. So let's take a look at some examples. An atom that has lost 3 electrons has a charge of positive or negative 3. Losing electrons is going to get rid of your negatives and make a positive charge. Right? Losing electrons, losing negatives makes you an overall positive charge. What about gaining 4 electrons? Gaining 4 electrons, taking on 4 new negative things, is going to make an ion with an overall charge of negative 4. Gaining electrons, taking in negatives, leads to a negative charge. Getting rid of electrons, removing electrons, right? Getting rid of your negatives leaves an overall positive charge. Now that's all well and good, but the deeper question that we have now is why? Why are atoms going to gain or lose electrons? What's wrong with an atom being neutral? Why do they need to become ions? And the answer to that is called the rule of 8. Now, if I were to draw the electron configuration for calcium, which has 20 electrons and 20 protons as a neutral atom, it is 2, 8, 8, 2. And we can take this directly off of our reference table. When we say valence electrons, and when we reference the rule of 8, we are talking about the outermost electrons. The outermost shell. This, that I highlighted blue here, these are our valence electrons. Valence electrons are always just the outermost shell, right? However many electrons you have in the last shell of the atom. And the rule that we're going to look at is the valence shell is most stable when there are 8 electrons in it or 0 electrons in it. Right, so one more time. The valence electrons make the atom the most stable when there are 8 or 0. And so, when we're looking at atoms and trying to see if they are going to become ions or what kind of ions they are going to become, we're looking at how many valence electrons they have and how many they either need to gain to reach 8 or lose to reach 0. In the case of calcium, it starts with 2, so it would either gain 6 electrons to reach 8 or lose 2 electrons to reach 0. And either one of these is going to make the atom stable. The only exception to this is helium and hydrogen, who only have one shell, and we know that that first shell can hold a maximum of 2 electrons, so it's never actually going to get to 8. So instead of 8 or 0 for helium and hydrogen, it is 2 or 0, filling their valence shell. Certain atoms are going to become ions in different ways. Some of them are going to gain, some of them are going to lose, some of them have the option to do either. And the way that we are going to determine Susan. The way that we are going to determine whether or not an atom will gain or lose to become a stable ion is by looking at which option is easier. And we can tell which option is easier by which one has the smaller value. For example, for calcium, it has the option of gaining 6 or losing 2. The gain and lose part isn't the important part, it's this number that's the important part. 6 is a lot more to deal with than 2, and so calcium will not gain 6. It will only ever lose 2. And we're going to look at some examples right now to kind of walk our way through that. We're going to look at sodium and chlorine. Sodium is element number 11. So as an atom, as a neutral atom, it has 11 electrons, which fill into the shells 2, 8, 1. And we know that because first we can look at the periodic table and just take the electron configuration right off of it. And we could also put the electrons in, as we learned how to do. If we look at the valence shell for sodium, there's 1 electron in it. So it has 1 valence electron, which means sodium has 2 options. Either gain 7 electrons or lose 1 electron. It will take the easier option, which is determined by which one of these numbers is smaller. So sodium will become a stable ion by losing 1 electron. When we go down to draw that ion, we have sodium with 10 total electrons and a charge of positive 1. It has lost an electron, it has a positive charge. And our valence shell now has 0 electrons in it, making it stable. Chlorine is element number 17. So if we look at a neutral atom of chlorine, it has 17 electrons in it, which fill the shells 2, 8, 7. And we know that again from taking it right off the periodic table, or filling our first shell and moving to the second, filling our second, moving on to the third. If we look at the valence shell for chlorine, it has 7 electrons in it, which means in order to become stable, chlorine can either gain 1 electron or lose 7 electrons. It will take the easier option, which is determined by which number is smaller. So chlorine here will gain 1 electron. When we go to draw the ion for chlorine, we're going to keep the atomic number the same because we still have chlorine. And because we've gained an electron, because we've taken in a negative, we now have a -1 charge. And our electron configuration looks like this: 2, 8, 8. The valence is now stable with 8. And so now we have taken 2 atoms and changed them into stable ions. And there's a couple of important things that come from this. Right? One just popped up in the chat, is that the noble gases are different. They're set apart, and the reason for that setting apart is because their valence shells are already full. If you take a look at the periodic table, the last column here is the noble gases, and they are stable because they start with full valence shells. They already have 8 in them, so they are not going to react with anything to form compounds. The second important thing that comes from this is looking at any compound that we've ever heard of. I picked sodium and chlorine on purpose because they make NaCl. Specifically, 1 sodium and 1 chlorine come together to make this compound. And if we think about what we just went through here, looking at sodium becoming Na+, and Cl, chlorine, becoming Cl-, that makes sense. 1 sodium and 1 chlorine can make a deal that makes both of them stable. Sodium can give 1 electron to chlorine, bringing it to Na+1 and bringing the chlorine to Cl-1. both of them end up stable because of this arrangement. As we move forward and look at more and more compounds and how these compounds are formed and how these atoms interact, we're going to see things like water, things like carbon dioxide. When these atoms come together to form these compounds, they're doing it in a way that allows the electrons to be moved around, shared, transferred, stolen, given, in some way that makes them all stable. That's why it's H2O and not HO2 or H2O6. Right? These ratios are set in a specific way because H2O is the way that makes two H's and one O stable. It's Na1Cl1 because it's a 1-to-1 ratio. When we look at these, we don't have NaCl3 or Na6Cl5. Right? It's a 1-to-1 ratio. One sodium can satisfy the needs of one chlorine. So that ratio, that agreement that gets made between the sodium and the chlorine makes both of them stable. And we'll talk more about that in later videos. But for now, we're going to transition our way over to our Google Meet for attendance, announcements, questions, comments, and concerns. And I'll see you there.